You could cross a river full of gold and never notice it. Most people think that finding gold is a matter of luck. They picture someone digging at random and sifting through the sand until something shiny appears at the bottom of the pan. But the truth is quite different. Gold almost never shows up where everyone is looking. And it's the physics of water that will determine where it hides. Finding gold in rivers isn't a guessing game. It's an exercise in observation, patience, and geological understanding. And today we're going to learn how to read a river like a geologist. First, we need to break a very common myth. Gold doesn't originate in the river. What we call river gold is actually alluvial gold. But its story began far from there. Gold originates in deposits called primary deposits, usually associated with quartz veins formed by hydrothermal fluids, ancient volcanic or tectonic zones, or very old rocks known as cratons, which are rich in metallic minerals. Millions of years ago, hot solutions rich in materials circulated through fractures in the crust, and as they cooled, precipitated minerals, including metallic gold. And soon after, over thousands or sometimes millions of years, these rocks were broken down by weathering, by rain, temperature changes, ice, wind, and chemical reactions, and little by little, tiny fragments of gold were released. Gravity took care of the rest. These fragments begin to move down the slopes, being caught by streams, then by larger rivers, starting a long journey. In other words, the river doesn't create gold, the river concentrates gold. The water acts as a natural conveyor belt. During a flood, it can carry anything from microscopic clay particles to huge blocks of rock. Everything enters this flow, but not everything stays in motion. And this is where the most important rule of this process comes in. Gold is just too heavy. Gold is one of the densest metals found in nature. It is much heavier than quartz, sand, or gravel. So when the current is strong, it can push the gold along with other sediments. But the moment the water's speed decreases even just a little, gold loses the battle against gravity and simply stops. And that's exactly how gold ends up hiding. So it's not because it's rare, but because it accumulates in very specific spots, controlled by the dynamics of the river's flow. From a geological point of view, the river acts like a huge density separation machine. So it's almost like an industrial mining machine, except it's sculpted by nature itself. The current will select, transport, slow down, and deposit these fragments. This process creates concentration zones called pay streaks, bands where gold actually accumulates. So learning to find this gold is, in practice, learning where the river loses energy. Now let's imagine the river seen from above. It never runs straight for very long. The riverbed is always forming these bends. And each bend creates two completely different environments. So on the outer part, the water speeds up, erodes, tears away material, and keeps carrying everything along. But on the inner part of the bend, the current slows down, and that's where the heavy material starts to settle. So coarse sand, gravel, and if there is any, of course, gold. Gold can also settle around obstacles. So whenever the water encounters a rock, it has to go around it. And behind that rock, a low-pressure zone forms. That is, a small area of calm in the midst of turbulence, which for us is a hydraulic shadow, and for gold, it's a definitive stopping point. The same thing happens in the cracks of the bedrock, so gold usually doesn't stay on the surface of the gravel for very long. It slowly sinks between the grains until it finds something solid that stops it from going any further down. When it finds a crack, it fits in there as if it were made for that spot and can remain trapped there for thousands of years. And that's why an experienced prospector spends so much time observing before digging. He's not just looking at the river as it is today. He's trying to imagine possible scenarios of the river during a flood. He's mentally reconstructing the moment when tons of water rushed through there with enough energy to carry heavy sediments and then lost strength at exactly a certain point. So prospecting isn't about digging, it's about interpreting this history of the flow. And another important detail is that alluvial deposits are not static. So unlike a mineral vein trapped in rock, river gold keeps coming. With every rainy season, new fragments flow down into the watershed. Some spots get depleted, others are replenished, but this system is always active, which means that a good spot that was depleted can start producing again after years, simply because the river has reorganized itself and the sediments. So when the material is finally collected and placed in the gold pan, we are just repeating the work the river has already done. The gold pan separates by density exactly as the current did before, only in a more concentrated way. And the circular motions we make allow the lighter material to be carried away by the water, while the gold, which is too heavy to escape, remains at the bottom. And in the end, finding gold in rivers doesn't depend on luck or persistence. It depends on us understanding three very simple things: how water transports sediments, where it loses energy, and how density controls what stays and what goes.